In this video, we're going to look at parabolas. We're going to graph parabolas with vertices at the origin. We're going to write equations of parabolas in standard form. We're going to graph parabolas with vertices not at the origin. And then we're going to do some applied problem solving parabolas. And this person I want to introduce you to, if you haven't already met her in the movie Hidden Figures, this is Katherine Johnson. And she was one of the pioneering mathematicians that worked on the U.S. space flight. So rock on, Katherine. Rock on, female mathematicians. You go. Here's some more information. I would suggest you pause this or go look her up yourself. Her name is Katherine Johnson. Rock star. Okay, let's talk about the parabola. So a parabola is a set of all points x, y in the plane. That sounds so familiar. I mean, we haven't talked about this a million times, but here it is again. That have the same distance from a fixed line called the Directrix. That is this fixed line down here, the Directrix, and a fixed point called the focus. This is the focus. And it is, of course, not on the Directrix. Now, with our parabolics, we have seen them before in Precalculus 1 when we were talking about quadratics in particular, and they were functions. Well, now our parabolas can be orientated, besides up and down, they can also be orientated left and right. When we would learn this in Precalculus 1, we still learned the Axis of Symmetry, but we didn't spend any real information on focus, the latus rectum, or we talked about the vertex, of course, and then we never talked anything about the directrix. So now we're going to have some more information, and that when we're talking about a parabola that we will be finding, and of course it will also open left and right. Parabolas have a lot of applications. You'll see them in cross-sections of headlights, flashlights, searchlights. The bulb, of course, is at the focus. The light rays from those point outward parallel to the axis of symmetry. Satellite dishes, field microphone, radio waves or sound waves parallel to the axis of symmetry are reflected into the focus. Cables, not all cables. You're going to say, well, wait a minute, aren't there other types of shapes? Yes. But some cables that are hung between structures and suspension bridges, such as the Golden Gate Bridge, has a parabolic shape. So we're going to start with the vertex at the origin. And so it's 0, 0 is where the vertex is. The focus is at 0 p. We're going to just start orientated where the parabolic shape is orientated up. The directrix is the line y is equal to negative p, because remember, this distance from the focus to the vertex is the same distance from the vertex to this directrix. Now, using the irregular distance formula and some algebra, we end up with the standard equation of an ellipse centered at the origin. First, we're going to be centered at the origin facing up or facing down. The directrix is the line y is equal to negative p. The standard form is x squared is equal to 4py. Now, we seen something similar to this in precalculus, but the way we would have seen it in precalculus is we would have seen this as x squared is equal to y, and we didn't worry about the 4p too much. And in fact, if we would have had 1/2 x squared is equal to y, we would have left it like that. Now, however, to make this in standard form, we would have x squared is equal to 2y. And then we'd say, okay, well, let's set the 2y equal to, or the 2 equal to 4p, and then that will tell us information about where the focus is located, it is in p, and where the directrix is located is y equals the opposite of p. And then, of course, the endpoints of the latus rectum goes through the focus, and it touches on either side horizontally or, in a moment, vertically or parallel to the directrix, touching the sides of the parabola, going through the focus. So now, like I said before, we are looking at parabolics that are left and right. In this case, the y will be squared, and y squared is equal to 4px. The directrix now is at x is equal to negative p. The focus is at p comma 0, and the endpoints of the latus rectum are plus or minus 2p comma p. Notice that this latus rectum is running parallel to the directrix, and it is going to go through both the sides as well as the center, where the center is, of course, the focus. So let's go ahead and find the focus, the directrix, and then graph the parabolic shape. For it to be in the correct form, it has to be y squared by itself. So we're going to put y squared is equal to, I have 1/2 x. Now that it's in the correct form, I know that 1/2 has to be equal to 4p. I'm going to divide both sides by 4, and I get 1/8 is equal to p. P is positive. That means we are opening to the right. My vertex is still at 0, 0. My directrix is going to be on the left side of the origin, so it's going to be x is equal to negative 1/8. My focus is going to be right here, which is going to be at positive 1/8, comma 0. And there's my shape. Not drawn to scale, of course, but that's my shape. For part B, I have my x squared already isolated, so I know that the 4y is equal to x squared. This coefficient on the non-squared variable, which in this case happens to be y, has to be equal to 4p. So 4p has to equal 4, so then p equals 1. P is positive, x is squared. That means for this one, I'm going to be opening up. So here's where my vertex is. My directrix, since I'm opening up, will be below the x-axis, and so this is going to be the line y is equal to negative 4. My focus is going to be right here. Here's my focus. It's going to be 0, 4, and then, of course, that's my shape. My last example here is I have 3y squared is equal to negative x. Well, remember, I want to have y squared. I want the squared variable by itself. So this will become negative 1/3 x. That tells me that 4p is equal to this negative 1/3. That means p is equal to negative 1/12. P is negative, y is squared. So I'm actually going to be opening to the left. So it's going to have some sort of shape that looks like this. Here's my vertex. My directrix is going to be x is equal to a positive 1/12, and my focus will be right here, which is negative 1/12, comma 0. That's where my focus is. Now I'm going to find the equation of the parabola with this given information. So I have a vertex at 0, 0. So that's the first thing I'm going to do is put my vertex. And then I'm going to pay attention to where my focus is, and that's going to tell me my orientation. It is 0, negative 4. So here's where my focus is. This is 0, negative 4. So then I know that this distance I traveled happens to be 4. So my p-value is negative 4 because I went below the x-axis. I went below the origin. My directrix then would be the line y is equal to positive 4. Now my equation, since I know it's orientated like this, it's going to be orientated so it's opening down, must mean that I have x squared. Now it'd be x squared 4py. Now I know what p is. P happens to be negative 4, so I have x squared is equal to 4 times negative 4y, which tells me my equation is x squared is equal to negative 16y. And that, let me just kind of clean that up, it's really hard to see. So this is equal to negative 16y. Once again, I'm going to draw where my vertex is so I can kind of get my orientation. So here's my vertex. My focus is at 10, 0. So here's where my focus is. This is at 10, 0. So I have to cup the focus. So I know it's going to be orientated like this. That means my directrix must be over here. X is equal to negative 10. I'm opening to the right, so that means my p is a positive 10. My equation should be the y squared is equal to 4p times x. So I have y squared is equal to 4 times 10x. And so my final equation is y squared is equal to 40x. And that's it. Now, of course, we can open left, right, up, down, not at the origin. Now, I want to make a note that the x's and h's are still buddies, just like the y and the k are still buddies. My vertex instead of the center is h, k, and it doesn't matter my orientation. My vertex will be h, k. Now, once again, we have all these formulas to figure out where everything is, and I don't memorize any of the formulas. I pretty much do counting, right? Because I can count. Most of the time I can count. And then, of course, when I open left and right, I have this open left and right. So let's take a look at these examples in which I'm asked to find the vertex, focus, directrix, and graph the parabola. So I pay attention to who is squared. It's y is squared. So I want to have y squared minus y is equal to. Because the y is squared, I'm going to move the x to the other side of the equal sign. I'm going to move the 6 to the other side of the equal sign. So I have x minus 6. I need to complete the square on the left-hand side, not the right-hand side, because the right-hand side is not squared. So I have y squared minus y, and then of course remember that we take this negative y, divide by 2y, we get negative 1/2, we need to square it. So that means I'm going to add 1/4 to both sides. So I'm going to add 1/4 here, and this is going to be x minus 6 plus 1/4. Now this shouldn't be anything new, except for now we only have to complete the square on one of the variables. And so the left-hand side is going to be y minus 1/2, the quantity squared. And on the right-hand side, I'm going to get x, and this is going to be negative 5 3/4, so negative 5.75. And now this doesn't quite match my formula. It should be y minus k, the quantity squared, is equal to 4p x minus 5.75. Now, if you remember when we were doing transformations of graphs and we said, wait a minute, that coefficient on x is not one I need to factor something out. Well, the coefficient is 1. So I'm going to just rewrite this as negative y minus 1/2, the quantity squared, is equal to 1 x minus 5.75. And the reason I'm doing that is so that I can clearly see that 4p will equal 1. That means p is equal to 1/4. Now my y is squared, my p is positive, so that means I'm going to be orientated opening to the right. My vertex is going to be at the point 5 3/4 and 1/2. So 5 3/4, comma 1/2. So I'm going to go 5 3/4 and comma 1/2. So here's where my vertex is. Oh, and you know what? I haven't talked about the axis of symmetry. I guess now is the time to talk about the axis of symmetry. The axis of symmetry is going to be this line. Has to go through the vertex, has to go through the focus. So this is going to be your axis of symmetry is going to be y is equal to 1/2, because that's the y part of the vertex. And since I'm opening to the right, my directrix and my axis of symmetry have to form perpendicular lines. Now I know that my p is 1/4, so my directrix is going to be the line x is equal to. I have 5 3/4 at my vertex. I need to go back 1/4, so this is going to be x is equal to 5 and 1/2. So 3/4 minus that 1/4 is 1/2. So that's my directrix. I remembered to do my axis of symmetry. Now I just need to find my focus. My focus will be here. So my focus is going to be, I am going to add 1/4 to the x part of the vertex. So that's going to make it 6, comma 1/2. So I found my vertex. I found my focus. I found my directrix. I found my axis of symmetry because I remembered. And I'm going to go ahead and draw this. And that's the sketch of that graph. So I'm going to take a moment because I kind of forgot about the axis of symmetry, and you'll need to know that. So I'm going to come back. You're like, darn it, why didn't you do that before? I just forgot. Please forgive me. It's just one of those things. Well, probably because up here, the axis of symmetry here is going to be the line y is equal to 0. The axis of symmetry here is going to be the line x is equal to 0. So really, that's not terribly interesting. Again, your axis of symmetry up here is going to be y is equal to 0, and this one is going to be x is equal to 0. So it's not really interesting, but we do need to talk about the axis of symmetry. So there, we talked about that. Now, let's go ahead and do this next example now that I have rectified the fact that I kind of ignored it before. So I pay attention to the fact that the x is squared, the y is not. So I'm going to write this as x squared plus 6x is equal to y minus 10. I need to move the y, the negative y and the positive 10 to the other side of the equal sign, because the only thing I need to complete the square on is the x. So I'm going to have x squared plus 6x. Now remember, I take the 6x, divide by the x, I end up with 3. I square it, and I add 9. So I'm going to add 9 here. Then y minus 10, I'm going to add 9 on this side as well. So I'm completing the square, nothing new here. So we have x plus 3, the quantity squared, is equal to y minus 1. So I know where my vertex is. My vertex is negative 3, comma 1. Now remember, I'm going to just rewrite this so I can clearly see that my 4p, because the coefficient on y is 1, my 4p should equal that 1. So p is equal to 1/4 again. Now, let's go ahead and graph this. My p is positive. I'm going to go to the vertex of negative 3. So negative 3, positive 1. So here's my vertex. My p is positive. My x is squared. I know I'm going to be opening up. So let's do my axis of symmetry. X is equal to negative 3. My directrix is going to be 1 minus, because my directrix will be below my vertex because my p is positive. So it'll be 1 minus 1/4. And so here is my directrix. It is y is equal to 3/4. And then my focus is going to be 1 plus 1/4. And so my focus is going to be really tight right there. So I'm just going to say focus is equal to negative 3 and 1 and 1/4. And so here is my graph. Of course, you all seen that I touched this. See how I touched that? There it is. Okay. Now, find the equation of a parabola with the given information and then graph it. The first thing I'm going to do is actually start the graphing process. I'm going to go to negative 3 or negative 2, comma 3. So negative 2, comma 1, 2, 3. So here's where my vertex is. And the reason I do that is because I need to know my orientation. My orientation is way down here at y is equal to negative 3. My axis of symmetry must run perpendicular, so that means that this must be x is equal to negative 2. The distance I traveled from my vertex, which is at a positive 3 for the y, all the way down to a negative 3 for my directrix, gives me a p of 6. So p is equal to 6. I have my h and I have my k, so I have x plus 2, the quantity squared, is equal to 4 times my p. And then I have y minus my k. So I have x plus 2, the quantity squared, is equal to 24y minus 3. Now, obviously, I didn't draw my parabolic shape very well. I know it's going to be opening up, but I didn't give myself enough space to find my vertex or my focus. My focus would be, of course, at negative 2. I'm going to add 6, because that's my p-value, to the y part of my vertex, which gives me all the way up to 9. So there's that. Now let's take a look at B and C. So once again, I'm going to start with where everything is. My vertex is at 3, 2. So I'm going to go 3. I'm going to go 2. Here's where my vertex is. My directrix is x is equal to negative 4. So I'm going to come over here and I'm going to say, oh, x is equal to negative 4. That means my axis of symmetry must be y is equal to 2. So that means I must be opening like this. Then it's just a matter of finding my focus. My focus would be, well, I'm going to count. How far did I travel from negative 4 to positive 3? That's my p-value. I traveled a value, my p-value is a positive 7. Now I know it's positive because my directrix is on the left side of my vertex. If my directrix was on the right side, that means I'd be opening to the left. That means my p-value would be a positive 7. Okay, so I have this, and I have this, and I have my focus. My focus would be, I'm going to add 7 to that 3, so I have 10, comma 2. So my equation is, now my y has to be squared because I'm opening left and right. So y minus 2, the quantity squared, is 4 times 7, x minus 3. So y minus 2, the quantity squared, is equal to 28, y minus 3. Lastly, we have this one. Don't panic. We're going to go ahead and draw it. We draw what we have. It's going to be, my vertex is at 0, negative pi. So here is 0, comma, negative pi. Pi is just a number, 3.14-ish. So there's where my vertex is. My focus is at 0, negative 3. Oh, so here's where my focus is, at 0, comma, negative 3 pi. So that tells me that my axis of symmetry is the line x is equal to 0. So that means I must be orientated in this direction. Remember, my parabolic shape will always cup the focus. I traveled a distance from my vertex to my focus, a distance of 2 pi. Now, that tells me that my directrix, it needs to come up 2 pi, and so this would be the line y is equal to pi. My p-value is the distance I traveled. In this case, because I am orientated downward, it's going to be negative 2 pi. Now I'm ready to find the equation. Because I am orientated with the parabolic shape facing down, I know my x is squared. So I have x, and I have minus 0, the quantity squared, is equal to negative 2 pi multiplied by 4. And then I have y. Y minus becomes a plus pi. So I have x squared is equal to negative 8 pi, y plus pi. And that is my equation. Now let's take a look at a couple of these applications. A spotlight has a parabolic cross-section that is 4 feet wide at the opening. So I can orientate it any way I want. I'm going to orientate it any way I want. I'm going to orientate it so my vertex is right there at 0, 0. And I'm going to orientate it because I like to have it this way. I'm going to orientate it this way. Now we know that across the side to side, that this point right here, this point is going to be 1.5 inches or 1.5 feet deep, so 1.5. And I know the total distance from side to side is 4, so this must be the point 2, comma 1.5. Because if this entire distance is 4, this distance must be 2. Now, you're thinking, do I have enough information to figure out how far the vertex is from the focus? And the answer is yes, because this is the equation x squared is equal to 4p and y. And guess what? I have an x value, I have a y value. All I'm really chasing is the p value. So my x is 2, the quantity squared is equal to 4p, 1.5. So I have 4 is equal to 4p multiplied by 1.5. And you're thinking, why didn't I multiply that? Well, because when I divide both sides by it, I'm going to get 1 over 1.5 is equal to p. And of course, we cannot leave this as a decimal with a fraction. So I could either write this as, because it's 1.5, so it'd be 3 over 2. So this is 2 over 3 is equal to p. So it's 2/3 of a foot. And that's it. Let's take a look at the next one. That I have a cable of a suspension bridge or the shape of a parabola. The towers supporting the cable are 600 feet apart and the height is 80 feet. If the cable touches the road surface midway between the towers, what is the height of the cable from the road at a point of 150 feet from the center of the bridge? Now, once again, I get to decide how I'm going to draw this. I could put my parabolic shape anywhere, but I'm going to put the place in which it touches the road at the vertex, and so I know it's going to have this shape. They also tell me that this is 80 feet, so this is going to be the point, comma 80. Now I just have to figure out my x value. My x value says, okay, well, the cables, the towers are 600 feet apart. So the total distance traveled is 600. So that means just this part to this point right here must be half of that, so 300. As before, I know that my x, the way I personally orientated, is going to be x squared is equal to 4py. Now, I have enough information to find p. Once I find p, then I can go back and actually answer the question. So I have 300 squared is equal to 4p multiplied by 80. So my p is going to be 281.25. Now, my equation is x squared is equal to 4 multiplied by 281.25 is equal, and then multiplied by y. Now let's go back and see what they want me to do. They want to know what is the height. So they want to find this y when x is 150. So I have 150 squared is equal to 4 multiplied by 281.25 multiplied by y. Now all I have to do is multiply 4 and 281.25 and then divide it into 150 squared, and I'll have my answer. And I get y to be 20 feet. And that's it for this section. Excuse me. We kind of like parabolas. They're pretty straightforward compared to some of the conics. This one isn't too bad. And that's it.